The topic of section 3.8 is implicit differentiation. And implicit differentiation is a technique that's used primarily with examples where we're unable to isolate y, or perhaps even if we are able to isolate y, using the original equation makes the work somewhat easier than it would be to isolate y and use our previous rules. Okay, so let's go through the process of this, and one thing to understand that's at the heart of this is that we are treating y as a function of x. Okay, so as we go through the process, you'll notice that the variable x and the variable y are treated differently in terms of, you know, how we go through the sort of algebraic process of this, or the differentiation. You know, that will be an important step in this process. So we start with x to the fourth plus y to the fourth equals 2. All right, so we know that the derivative of x to the fourth is 4x to the third. Okay, that's the power rule. And now you might think, okay, so the derivative of y to the fourth is 4y to the third. Well, not exactly. It's going to be 4y to the third dy dx. Okay. And let me take a moment and explain that, because that is, you know, again, that's what distinguishes this from what we've been doing. The fact that we're treating y as a function of x here. So we're really using the chain rule here to go from here to here. We're treating y as the inside function. And so the chain rule says, you know, you're going to get derivative of the outside function, leave the inside function alone, multiply by the derivative of the inside function. Well, the derivative of the inside function is dy dx. If you prefer, you can write y prime, dy dx and y prime mean the same thing. I tend to prefer to write dy dx when I'm doing implicit differentiation, only because it's easy to mix up y prime and y to the first. So just to make it, you know, stand out, I prefer to write dy dx here. We need to take the derivative of the right-hand side of the equation as well. In this case, it's a constant, so the derivative is 0. All right, so in an implicit differentiation problem, we're always looking for this dy dx. We take the derivative of both sides. This is what we got in this case. Now we want to solve for dy dx, and this is the algebra part of the problem. I'm going to subtract 4x cubed from both sides, dy dx. Oops. Cubed. Divide both sides by 4y cubed. And so we have dy dx is negative x cubed over y cubed. Notice our answer here includes both x and y in the answer, which is unusual. We haven't run into that before when taking derivatives, because we ordinarily have y as the dependent variable, x is the independent variable. We take the derivative and we get the derivative of y simply in terms of x. Now it's in terms of x and y. And that's pretty common with implicit differentiation. It doesn't always come out that way. You could have dy dx just in terms of x. Sometimes you might have it just in terms of y, and often you'll have a mix of the two. And any of those is fine when you're doing implicit differentiation. Part B says find the slope of the curve at the point 1, -1. Okay, so this equation represents a curve, not necessarily, when you're doing implicit differentiation, you don't necessarily have an equation that represents a function, because it may not pass the vertical line test, but you have a curve of some kind, and so here we're given a point, and in order to find dy dx at that point, take the x and the y and substitute in here. So -1 cubed over -1 cubed. That's going to be -1 over -1 or 1. So whatever this looks like, okay, and they didn't ask us for more than we've done here, but we know that this curve is going to have a slope of 1 at this point. Okay, that's what we're determining. Let me point out, just to go back to this idea of this may not be the graph of a function. 1, 1 would also be a point on this curve. It satisfies that equation. And the reason I point that out, that's going to have a different answer if we had 1, 1 as our point. What that illustrates is that we need both x and y here to know the slope of the curve. And that's something that's new for us. You know, usually if we want to find the slope at a point, we just need to know x. Well, you know, if there's more than one point for a given x, we need to know both x and y. And that's something that we see here. Okay, so that's an implicit differentiation problem. Hope that helped. See you in the next video.